best fit, we're discussing today how to find line of best fit, or what does line of best fit look like. And then we are going to use the line of best fit to make a prediction, because again, a line of best fit is just identifying the projection that the scatter plot is moving towards. So, go sneeze. Thank you. Okay. Thank you. All right, so we have an example here of some data that was collected. This should look kind of familiar to you, because yesterday we had in our Nearpod the discussion of a positive association that was linked between temperatures outside and ice cream sales. So we know as the temperature is increasing, the sales of ice cream, or how much money is profited from ice cream sales, is going to get bigger. So as one increases, the other increases. So don't get fooled. This is not 14 degrees for us. This is 14 degrees in Celsius, which is a bit higher. So here, as we're seeing a trend of the temperature, going up, and sometimes it's going down. These are recorded on different days. That's how scatter plots work. Sometimes it might go up a little bit, might go down a little bit, go back up again. It's following those trends, but it's basically been reported over a series of 12 days. And then what the price is, or the profit was earning from those days. And we'll notice that as the temperature was at its highest point, so was the profit. The profit seemed to be at its highest point as well. So I didn't want to have to worry you guys on graphing this yourself, because I know it can get a little bit tedious. But what I've gone ahead and done is graphed it here for you. So this is what that same data looks like as a scatter plot. We know that it is a positive association. We already discussed that yesterday. We do see that it is, for the most part, linear. And what we're going to try to do is understand how to use a line, an actual equation, to represent this situation, and then use it to be able to make some predictions. So the nice thing about line of best fit is that there are a lot of possibilities. Okay? There are a ton of different lines that you can construct that actually would be a reasonable estimation. But there are also a lot of incorrect solutions as well. So what's important to understand, if you want to go and flip this on over to your back, when we're creating a line of best fit, it's important to make sure that the line that you create is as close as possible to the points. It doesn't have to go through every point. It might go through some, but what you want to make sure is that you've got almost an equal distribution of points above the line as you do below the line. So when you are constructing these lines, and yes, you are going to be constructing lines for yourself tomorrow, as you're constructing these lines, you're wanting to construct it in a way that you've got an equal distribution above the line as you do below the line, or an almost equal. Okay, you want to make sure that it's going centered through the pathway of the points. Okay, so what we're going to do here, and again, you might want to highlight this little piece of information right here. It's as close as possible to all the points, and that you have as many points above the line as you do below. So we call that an equal distribution. So that's really important to make sure that you have an equal distribution of your points. Okay? All right, so what we're going to do is we're going to go ahead, like I said, these notes are very quick and easy. The only way that you can actually learn about line of best fit is to construct or practice creating these lines of best fit. So I'm very happy that quite a few of you have your colors out. You're going to need them for today. Okay, so let's go ahead and take a look at the very, very back. What we're going to do is we are going to plot these lines that they have provided for us, and we're going to identify which of those lines would be considered a line of best fit for the scatter plot provided. So what I'm going to do is I'm going to go ahead and plot line A with my pink. I'm going to do line B with my green. We're on the last page, honey. Line C is going to be in my blue. And then we'll do line D in purple. Okay? So we have these lines that we're going to go ahead and construct. So remember, when we are constructing our lines, we plot our y-intercept first. So for line A, our y-intercept is at the point 0, 80. So we're going to plot the point 0, 80, which is right up here. And then we're going to use our slope. I'm either going to go down to, well, actually, yeah, that's what I'm going to do. If I go up and to the left, I'm going to go off my grid. So I'm going to go down to, and then to the right, 5. I'm going to go down 2 and then to the right 5 in order to be able to get to my next point. Now, each of these grids happens to be counting by the same amount. Each of the grids happens to be moving. Each box is worth 5. If you notice at the bottom, it goes 0, 5, 10, 15, 20, 25, 30. And then same thing for here. We've got 40, 45, 50, 55, 60, 65, 70, 75, 80. So since they all happen to be by the same interval, they are all counting by 5s, then I can use my slope and just count by boxes because the intervals are the same. That's the only time that you're allowed to count by boxes is when your intervals are the same, okay? So I can go 2 boxes down, and I can go 5 boxes to the right. 1, 2, 3, 4, 5. Here's where a point would be plotted. I can count 2 down again, and then 5 to the right. And I can keep on with that trend. 2 down, 1, 2, 3, 4, 5 would be off the graph a little bit. Okay, so I have this as my line that I've created. Now, if you've got a straight edge, you can go ahead and connect them. If you don't have a straight edge, then I wouldn't bother doing it because it's not very useful without a straight edge. Does that look like it's a proper line of best fit? No. So this is not going to be a good line. So I'm going to go ahead and put an X right next to it. It's not a proper line of best fit because majority of the points, almost every single point is falling below the line. Okay, almost every point is falling below the line. So what do you think seems to be the problem? Do you think the problem is the y-intercept, or do you think the problem is the slope? So that's what I want you to start thinking about. If we had a different y-intercept, meaning if we took this whole line, kept it at its same inclination, its same incline or steepness, and we just moved it down a little bit, do you think that that would be okay? Mm-hmm. Yeah? Okay, Lucas thinks it's okay. How many of you think that you need to keep it at 80 and maybe you need to change the incline a little bit? So you want to think about these things when you're looking at this stuff and try to gauge what could be a better solution. The correct answer is both. Both of them would be correct solutions. If I were to keep the same exact slope, but maybe just change my y-intercept a little bit, move it down a little bit, maybe move it to, I don't know, 70 or somewhere between 70 and 75, that would give me a lot better of a line of best fit. Maybe if I kept it at 80, but I increased the size of the slope, so maybe instead of -2/5, maybe my slope became, -6/7. That would give it a different look. It would make it a little bit more steeper, which would have it running through some more points. Okay, so there's different solutions. Like I said, there's an infinite possibility of lines that you can create for best fit. All right, so let's take a look at problem B. Problem B has us keeping that same slope, but it has us changing the y-intercept. So we have 0.75. So I'm going to go here at 0.75. And then, of course, like before, we're going to go down 2, and then we're going to go to the right 5. Down 2 and to the right 5. So down 2 boxes to the right 5 boxes. Down 2 to the right 5. Down 2 to the right 5. Okay, from here, when I graph it, this is a very good representation. Okay, we have a nice distribution of points above the line as we do below the line. But like always, you want to check every single line that they have given to you. You want to make sure, because it's called line of best fit. This is a good fit, but we don't know if it's the best yet. Okay? Now we're going to do y is equal to 60. That's one of those special lines. Who remembers what does a special line of y equals look like? Hassan? It's a zero slope. So that means it's at a horizontal line. This is a zero slope. So that means it's going to be a horizontal line at the point 0, 60. So where it says 0, 60, this is the line that we're graphing here. Is that a line of best fit? No, that's obviously not a line of best fit. It doesn't follow the pattern at all of your scatter plot, so that would not be considered a line of best fit. We can go ahead and cross that off. Okay, so the last one that we're going to look at has exactly the same y-intercept as graph B, but it has a slightly more inclined or steeper incline of a slope. So we're going to check and see how that one looks. So again, your y-intercept would be at 0, 75. But this time you are going to go down 3 and then go to the right 5. You would go down 3 and then to the right 5. So starting at 75, so our green and our purple are overlapping right there. We're going to go down 3 boxes, 1, 2, 3, and to the right 5. 1, 2, 3, 4, 5. Down 3, 1, 2, 3, to the right 5. 1, 2, 3, 4, 5. And then down 3 again. 1, 2, oh, we're going to go off the graph. And then 1, 2, 3, 4, 5. Okay, so here would be our purple graph. Is that a good line of best fit? No. So it has a nice starting point. It has a nice choice for the y-intercept, but the slope is too steep. So the best choice is going to be graph B. This is the best choice, graph B. Okay? What I want you guys to do is you're going to do the exact same thing for those 2 problems at the bottom. You're going to graph all the lines. We're going to do just like we did before. You're going to graph lines A in pink. You're going to graph lines B in green. Line B's are going to be in green. You're going to graph line C's in the blue. And then your line D's are going to be in the purple. You're going to do that for both of them and see which one you can identify as your line of best fit. Yes, dear. Absolutely. Yes, you can work with your group. Yay. Okay. All right, so we've graphed the points for plot A. Again, they all start at 0, 0 because none of them have a y-intercept written. We went up 4 to the right one or down 4 to the left one. They're all going in the same position, and it's going to form a graph that looks like this. Obviously, that is not a line of best fit because it is way too steep. So we're looking for something that's not quite as steep, which means graph B is also not going to be appropriate because graph B is just going to be in the opposite direction because it is a negative slope. So that obviously is not going to be a proper graph as well. So that means we're going between C and D. I can, right off the bat, without having to graph, I can just say it's going to be C. The reason I know it's going to be C is because C is the only one that has a positive slope. And this is a positive correlation or a positive trend. So I know graph C is the one that I'm going to have to go with. Sometimes there's things that you can look at and you can immediately eliminate because, like, for example, up here, we should have didn't even have to graph C. We could immediately eliminate a horizontal line or a vertical line because it's not a proper trend. We can immediately eliminate negative slopes because this is a positive trend. So here I'm going to graph the 1/4 going up 1 to the right 4, or in the reverse going down 1 to the left 4, and it gives me this as my trend. Okay, and that is a proper trend line. So graph C is what's going to work. With the last one, again, all of these are starting at either +2 or -2. So we have to take a look at them. If I'm starting at +2, I'm starting right here, and then my slope is going up 1 to the right, up to the right, but there's a problem because I'm going in the wrong direction, aren't I? So this obviously not going to work because I want to go into a negative direction. So if I take a look at graph B, starting at +2, going up and to the left, or down and to the right, this is what it looks like. Okay, and that is a pretty good trend. I know that these are not going to work because they have me starting way too low. Like, for example, if I'm looking at the purple one, which is also a negative slope, it has me starting at -2, and then I'd be going in this direction. I'm way beyond any of the points that I would need to be hitting. So, obviously, graph B is going to be our best one. You have an assignment on Google Classroom. It is going to be a quizzes. I'm giving you 2 attempts. I'm going to give you 2 attempts on this one. Make sure you use it.